Okay, so all we're really doing today is talking about what we have done for the last 2 weeks, essentially. And so we started out by testing a mean mu using the critical region method. So this was like section 8.2. And then we did the same thing, but for proportions, right? So we talked about the critical region method for proportions in 8.2. And then we moved on to talking about this thing called the p-value method. And the p-value method was 8.3. And so I'm just going to kind of wrap it all up, bring it all together. And at the very end of this, there are some practice problems that we're going to start. And so the requirements of every single time you're testing the mean, regardless of if you know sigma or not, these are the two things that you have to check for. And so what kind of sample do you always absolutely need to have? Yeah, it absolutely has to be random. And then you need your X bar distribution, that sampling distribution, to be normal. You can either get it by just like being told that X is normal, right? If X is normal, then X bar is normal. Or what does N need to be bigger than or equal to? Yeah, 30. And so these are the two things that you need to check for every single problem that involves testing mu, right? Involves testing the mean. And so after that, there's two different ways that you can solve the problem. There's either a critical region method or there's the p-value method. And remember, the critical region method only works when you are given sigma. If you're not given sigma, you cannot use the critical region method. You have to use the p-value method. So here, that's the first thing. Follow these steps to perform a hypothesis test for mu when sigma is known. And then these things are pretty much, it's the same format that you guys have been doing, right? You need to state your null and alternative hypotheses. And then what you do after you state those two things is, okay, just set it paused. Can everybody like hear me okay? Okay, that was weird. Okay, so yeah, the next thing that you're gonna do is you use, which function in your calculator can you use? Oh wait, hang on, never mind, I skipped a step. Here, you're gonna use the significance level. And what variable do you use for the significance level? It's not, Z is the next thing that we have to find.
Alpha.
Yeah, it's alpha. And so here, the significance level is alpha, and then the third thing is when we find Z, which is the test to statistic. But you use alpha to find your critical value and your critical region. And then here, this one is going to be Z. What function in your calculator do you use when you're given sigma, though, to test a mean mu?
Z-test?
Z-test, yeah. So you're going to use the Z-test function to find the test statistic Z. And so when do you reject the null hypothesis? Where does the test statistic need to be? So if the test statistic is in the critical, what should I put here? Yeah, if it's inside of your critical region, right? And so here, if your test statistic is inside the critical region, then we reject the null hypothesis. And then the very last thing that you do after finding all of those things, you're going to interpret your conclusion in terms of the problem. And then down here, this is what I was talking about. When sigma is unknown, can we use the critical region method? Can we use any of this? No, instead I have to use the p-value method, which I'll talk about in a second. But are there any questions about the critical region method? Right here is the picture, right? So this is your critical value, z sub c, which is step 2, right? So you're going to use the significance level to find z sub c. So here, let's put this here. And then your critical region, if it's left-tailed, it's going to be like negative infinity up to z sub c. That would be your region. So here, critical regions. Here, where does my critical region start if my test is right-tailed? Do you guys remember this interval notation? Yeah, it's the right side. So then my interval should have positive or negative infinity, or both. Yeah, positive. So you guys remember this kind of? So my critical value is where my critical region starts, and then it's going to go all the way up to infinity. I know it's been a while since we've talked about this, but is everybody kind of remembering this? Okay. Okay. So yeah, here's another critical region. And then this one, this is the one where you have both positive and negative infinity. So you start at negative infinity, right? And then you go up to negative z sub c. And then you skip all of this. And then you start at z sub c and go to positive infinity. And so essentially what you're doing is you're finding this. So all of this, what I just talked about, is just step 2, right? Step 3 would be finding your actual test statistic. And then what you do is you say, okay, if my test statistic is here, so if z is less than z sub c in this case, then it's an unusual value and it should be rejected. So if z is there, then you would reject h naught. But if z is like, if I look at the right-tailed test, if z is here, is that considered unusual? Should I reject h naught at that point?
No.
Yeah, no. And so this is essentially the critical region method in pictures. But so yeah, so here, do not reject. Are there any questions about this critical value method? All right, I'm going to start talking about the p-value method now. And so the p-value method, you can actually use this regardless of what you're testing. So we're still talking about mu in this case. So still testing mu. And so what we're going to do is you can test this when either sigma is known or unknown. So this method works for both cases, while the critical value method only works if you know sigma. And so the very, very first thing that you need to do is check the requirements. It's the same requirements from above. So same as on previous page. And then you state your hypotheses, the null and alternative. And then here, this is where it starts to change from the critical region method. So you don't need to find the critical value or the critical region, but you do need to find the test statistic still, which is given by, in this case, since there's two different cases that you could have essentially, right? Either you know sigma or you don't know sigma. This could either be Z or T. When is it going to be Z? When you have sigma or when you don't have sigma?
When we have sigma.
Yeah, when you have it. And so when you don't have sigma, that's when you have T. And so here, after you find the test statistic, well, I mean, it'll be on the same screen. You're also going to find the p-value. And so here, if sigma is known, you guys told me earlier, you use the same z-test, right? So in the critical region method, you use the z-test function in your calculator to find just z. But now with the p-value method, you're also going to use that p that comes right after the z. And so here, this will give you z and p. But if sigma is unknown, then you're going to use the t-test function, and this will give you t and p. And so remember, if you look down here at these pictures, so I'm going to scroll. If you look down here at these pictures, this is what's showing you what the p-value method is. So rather than the area of this piece being alpha, because this is not the critical region anymore, what this is this is just the area to the left of our test statistic, which is either, it could be Z or it could be T. So Z or T, right? And then the p-value is the probability of that section, right? But it's not the critical region. And so this is kind of what, if you were here on Wednesday, this is kind of what I had talked about a little bit. And so what this is doing is you make your conclusion based on p-value and the significance level. Remember, the significance level is alpha. And so if your p-value is greater than alpha, am I going to reject or not reject? And so before anybody answers that, let me put it this way, right? So if my p-value is greater than alpha, then that means that my probability, like this section has a bigger area than the significance level, right? So if I were to find my critical region, so let's say this red portion is my critical region, then basically what this is saying, when your p-value is greater than alpha, it's saying that your test statistic is not unusual. So am I going to reject or not reject? Yeah, you're not going to reject. So this is the critical region and the area is equal to alpha. And so here, if your p-value is greater than alpha, you do not reject. But if your p-value is less than or equal to alpha, so I'll do that on the right-tailed test, right? If I have my unusual values is here, then here's my critical region. And so the probability that your test statistic is unusual is like, it's an unusual value. And so in that case, I'm going to reject. So here, let's say this is the critical region. And I kind of destroyed that picture. Okay, so, oh yeah, then the last step, always interpret your conclusions. Always, always, always. But do you guys now see the difference between the p-value method and the critical value method? Like, is it very clear, the difference between them? One person said yes. So James gets it. Emily gets it. Thank you. So yeah, because what I'm worried about seeing is I don't want you guys to start mixing up these methods, right? And so if you guys start mixing up the methods, it's just going to be bad. So make sure you don't do that. And so here, let's kind of go over real quick. So your conclusion is either based on if your test statistic is in your critical region or if your p-value is like greater than alpha, right? And so don't start pairing p-values with critical regions because you can't, unless you talk about it this way, the way I had it here drawn out, it's very easy to mix them up. So make sure that these make sense and that you can very easily tell the difference between them. And if you can't, then ask me and I'll help you. But yeah, so are there any questions about how to test for a mean mu? If not, we're going to start talking about proportions. Okay, does everybody have everything written down on this page? Can I scroll?
Yes.
Okay. I guess when I ask that question, you guys can just type like no, don't scroll or something like that. But yeah. All right, so here, let's talk about testing a proportion P. And so again, when you test a proportion P, you can use either the critical region method or the p-value method. And it's basically the same thing. You just have some different variables that you're going to be looking for here, right? And different calculator functions that you're going to be using. But again, the very, very first thing that you need is you need a simple random sample. That's just always true. But then when you check for normality, it's no longer that you're looking for n is greater than or equal to 30. What are you checking for? What are the two things that you want to look at? Okay, yeah, so what are the things that you want to find? So before it was that n was greater than or equal to 30. But here, when you're testing proportions, you don't look for n being bigger than 30. You look for two values, and you want to make sure that those are bigger than some other value that's not 30. And so what are the two things that you're looking for? N is one of them. Yeah, so it's NP and NQ. And so here, I'm going to show you guys something real quick because there's two different ways you can think about this. It's, you guys remember that p hat is equal to like x over n, right? Oh, she needs a password. If she clicks the link, it should just let her get in. But hang on, let me look for that password. I don't know how to find the password. Yeah, tell her to click the link from Blackboard and she should just get in automatically. I'm not sure why it's telling her she needs a password. And I don't know how to find it. I'm gonna continue for now though, Brittany. Yeah. But okay, so yeah, here, back to what I was talking about.
Sam, on mine it says that the password
Okay,
is
that's weird.
0.
Make sure she's copying the whole link and not just like half of it. Or like missing a letter at the end or something like that. Because yeah, I can't figure out how to find this password. Okay, but yeah, so p hat is equal to x over n. And so there's two ways that I've given it to you so far. I've told you that x and n minus x need to be greater than or equal to 10. But I've also told you what somebody typed in here, right? I've also told you that n times p and n times q are greater than or equal to 10. These are the same things. If you look over here, if I just multiply both sides of this by n, you get that n is equal to n times p hat. Oh, thank you, Deanna. I'm not sure how you found that. How did you find that? Is it in the link? It might be. Oh, weird. Okay. I guess that works. Thank you, Deanna. So Brittany, I don't know if you saw, but she typed it. Yeah, okay. But yeah, so you can either check these two, you can either check the two things in red or you can check the two things in blue. They're essentially the same exact thing though. And you just want to make sure that those are greater than 10 or equal to it. But is everybody okay with that? I'm sorry, I know we got kind of sidetracked. Okay. All right, so, and then yeah, here, remember that X is the number of, what am I trying to put here? Yeah, successes. You can kind of think about this as like the number of people that responded positively. That's kind of another way that you can think about it. Or it could also be the number of people that responded negatively. Either one, you can switch it for based on like which one you care about, I guess. But so here, these are the steps that you're gonna follow when you're testing P. Remember, so if you're given a percentage or if you're told that 67% of people like this thing, then you're gonna be testing for P and not mu. And again, the very first thing that you need to do is check the requirements. And then you need to state your hypotheses. And the null hypothesis, so here, yeah, here you're gonna have H naught colon P is equal to, and then I'm gonna use P naught. That's what your calculator asks for, right, is P naught. And so that's how we'll write it here. And then your alternative, that's where you have H1, and then P, and then here you can either have less than, greater than, or not equal to P naught. So you kind of have to like choose one of these, I guess. And then the third thing that you do is you look for that critical value. Since this is the critical region, right, you're going to use your critical value. And so what is the variable that we use for critical value again? It's Z, and then it has something else attached to it.
Z sub C.
It has a little subscript. Yeah, it's like the Z sub C. To type that, you would type Z underscore C. That's how some people do it. And then you're gonna use, which function in your calculator do you use? Yeah, one prop and then Z test. And then this is where you find Z, right, which is the test statistic. And then you're gonna, again, interpret your conclusion. So this critical value method is essentially the same thing as it is for testing the mean. You just essentially have different requirements that you're checking, and your null and alternative hypotheses are gonna look different. And then the p-value method is almost exactly the same. And so I'm gonna wait a few more seconds and then I'll scroll to that. Okay, can I scroll? Is everybody done with this page? What page is this? This 4? 3. So I'm gonna go to page 4 if there are no objections. Okay, so let's talk about the p-value method. Oh, where did my pencil go? Here it is. So the p-value method, again, it's almost the same thing. So you check the requirements first. You state your null and alternative hypotheses. Oh, I didn't realize I put this sentence in here twice. Yeah, we didn't need to write this out again. But it's the exact same thing that we had up there. So H1 is either less than, greater than, or not equal to P naught. But then here, this is where it starts to change, right? And so you don't find critical regions anymore, but you find your test statistic Z. So test statistic Z and the p-value. Oh, I didn't put it here, but what function in your calculator do you use? So using, what do we use here again? Not the t-test. The t-test is only if you're testing mu without sigma. But here I'm still testing p, so yeah, it's still one prop z test. And so that's the thing, from the critical region method to the p-value method, what really matters is what you're testing. That tells you what your functions are, not which method you're using, right? And so I'll write that down in a bit. But so yeah, using one prop z test. And then you make a conclusion based on the p-value and the significance level alpha. And again, this is the same thing as it was up when we were talking about mu. If your p-value is greater than alpha, do not reject H naught. And if your p-value is less than or equal to alpha, then you are going to reject H naught. And then, yeah, the very last thing is to always interpret your conclusion in terms of the problem. So remember how I was just like copying down essentially the problem statement whenever I would do an example? We'll probably get to one today. And so yeah, that's basically the summary for everything. Before, or here, let's do this example and then I'll try and draw out like a little kind of map for you guys. But so here it says draw a picture for each test that relates the p-value method and the critical value method. That's kind of what I was doing earlier. But so if I look at a left-tailed test, so that's the first one I'll look at, then let's say the blue is my critical region. So I'll have a little legend down here, critical region. And so that's my critical region. And so that's basically the region of unusual values. What's the area of this region given by? Oh, I wrote it. It's alpha. Sorry. Anyway, so yeah, that's alpha. And then if I look at the p-value method, so I'll put the p-value in red. Then, oh, hang on, I forgot. So with the critical region, this blue line, this is given by the z sub c, right? Your critical value. But then when I do the p-value method, yeah, with the critical value method, you still have to make a conclusion. So I think, oh yeah, interpret the conclusion. I missed the step about actually finding the conclusion. You're right. So yeah, here, maybe just make a little note, like need to actually make a conclusion. So that would be step 5, and then step 6 would be to actually interpret it. Okay, so going back down here, if I look at the p-value method, then what this is doing is if my test statistic is here, So there's Z, and remember, if I'm just looking at the critical region method, if Z is inside of the critical region, I'm gonna reject. And here, the p-value method says that if your p-value is less than alpha, then you reject. And so in this case, we have both that Z is less than Z sub C, or here, let me write it this way. Z is in the critical region. So reject. But for the p-value method, what we have is that our p-value is, if you look at it just area-wise, you could see that this part is smaller than the blue part, right? And so you have that your p-value is less than alpha, so reject. Does everybody see, is this picture clear to everybody what I'm talking about? Okay. And you could do it for the other tests as well, right? If I had a right-tailed test, then it would just look like this. That's a bad normal curve, but that's okay. And so if this is Z sub C, I could make the same conclusion, right? If this is Z and here's my p-value, what I wrote right here is still true for this graph as well. And it would be if I drew the double-sided one, or the two-tailed test. So are there any questions about these pictures that I just drew, or the difference between the methods at all? So what I'm gonna say now then, so when p is less than, we don't know, when p is less than alpha, that's when you reject, right? So p is less than alpha, so you're gonna reject. Here, so this is the p-value. This one is alpha. If you look, so don't think about it in terms of like on the number line, because these are not like representative of numbers. If you look at the area of this, you can see that the red piece is smaller than the blue piece, and so your p-value is still less than alpha. And so here, like if you kind of think about it in terms of like, if I drew alpha as a square, then p-value would be like a square that's like that big. And so if you can fit p inside of alpha, that means it's smaller than alpha. Does that make sense? Okay. So yeah, the p-value is smaller than alpha whenever you can actually stick it inside of the piece that alpha takes up. But so let me talk about when to use which calculator functions, and I'll put that in green, and I'll kind of separate it down here because I didn't plan on writing this. But so basically, if you are given mu and sigma, what calculator function are you going to use? Regardless of the method that I tell you, you can use either critical value or p-value. Yeah, you're going to use z-test. But if you're given mu and s, which is the sample standard deviation, you can only use the p-value, but then yeah, you have to use t-test here. And so here you can use critical region and p-value. Here you can only use p-value. Oops. And then the last one would be given p or p hat or x and n, all of these things, right? What function are you going to use? One prop z-test. And here, again, you can use either the critical region or the p-value method. It's only this second one right here, the one that I just starred, that you cannot use the critical region method for. Sorry, so I zoomed out a little bit so that so that everything was there. So are there any questions about the summary before we start one of these examples? I'm probably just gonna do an example for you, and then I want you guys to work on the other two at home. And I might actually ask you to turn them in. so that we can talk about them on Monday. So does everybody have this? Can I scroll? Are there any questions about this? I'm gonna start moving this. Okay. So this example down here is basically saying that there was a poll conducted in 2011 and 55% of the people that responded said that owning a home is part of the American dream. And so it says, suppose this result was true for all American adults in 2011. So that means this 55%, oops, hang on, let me change this to blue. What variable does this 55% represent? It says, suppose it was true for the population. Yeah, so this is now P. And then it says, in a recent poll of 1,800 American adults, so what does 1,800 represent? N. And let's pretend that this says in a recent random poll, because it should always say random. It says 61% said that owning a home is an important part. And so yeah, this 61% is gonna be our P hat. And so this is one of those ones where if you look at your calculator, when you try and use one prop Z test, you're gonna have to find P hat, or not P hat, you're gonna have to use P hat to find X. And so it says, perform a hypothesis test to determine whether it is reasonable to conclude that the percentage of all American adults who currently hold this opinion is higher than 55%. And that whole sentence right there is essentially what we're going to copy into our conclusion. And we're going to say either, yes, it's reasonable to conclude all of this, or no, it's not reasonable to conclude all of this. What is this 2%? Yeah, this is alpha, but do I have that alpha is equal to 2? Yeah, you're gonna have alpha is equal to 0.02, right? Because you need to convert it to a decimal. And so real quick, let's just kind of write a summary. So we've got P is actually 0.55. It's not 55. You have that P hat is equal to 0.61. N is equal to 1,800. And alpha is equal to 0.02. And so here, how do I find X again? X is gonna equal what? It's N times P hat. So you guys are all really close, yeah. And so here, I'm gonna have that X is equal to 1,800 times 0.61. So if you think about this, X is the variable that represents the number of people that said yes to this question, right? Is this a very important part of the American dream? Either yes or no. And 61% of those 1,800 people said yes. And so that's what this X is doing. It's saying 61% of this 1,800 is how many people said yes. And when you do that, you get, what is it? 1,800 times 0.61. 1,098 people said yes to this question. Oh, thank you. I didn't see that you guys have typed it. And so that's X. And so when you go into your calculator and it asks for X, that's what you should give it. Okay, so now that we have found the variables, we can start checking everything. And so the very, very first thing that I do is I look at the requirements. And so I wrote random in there. So yes, it's random. And then here, since I'm looking for P, what are the two things I need to check for? Yeah, and so you can do it one of two ways. I prefer the X. So is X greater than 10? Yes. And then is N minus X greater than 10? And so here, N minus X is going to equal 1,800 minus 1098, which is going to be like 700 something. And so, yes, it's greater than 10. Thank you, James. And then what's the second thing I do after I check for those requirements? Yeah, I'm going to state my null and alternative hypotheses. And so my null is that H naught, and so I'm going to have that P equals, and then what value should I put there? What do I think P is equal to? .55, yeah. And then H1, what sign? So I know I'm going to have P is something 0.55, but what sign should I have there? Less than, greater than, or not equal to? Greater than, because it says higher than right here in the problem. So yeah, P is going to be greater than 0.55. And so then now that I have my null and alternative hypotheses, I didn't tell you which method to use. Oh, and I just realized we only have 3 minutes left. So we'll finish this example on Monday, just to give you guys some time. So yeah, we'll finish this on Monday, but I do want you guys to start looking at the other ones. Try and finish this one if you can too. We are going to be starting some other notes on Monday as well. We're going to start talking about confidence intervals. Oh, I'm also going to stop the recording now, if I can figure it out.